Good morning, students. The topic we are going to discuss is linked list implementation of list ADT. So what is linked list? What is singly linked list? It is the simplest type of linked list in which every node contains some data and a pointer to the next node of the same data type. A singly linked list allows the traversal of data in only one way. You can traverse the list in a single direction. You can perform some operations on linked list such as traversal, searching, insertion, then deletion and so on. So these are some of the operations that we can perform with singly linked list. So first one is traversing a linked list. What it is? Traversing is nothing but visiting the nodes. Accessing the nodes of the list in order to perform some processing on them. So this is the algorithm for linked traversal, linked list traversal. We have to set the pointer as the starting node. Then we have to process the data on that node. After processing the data on the first node, we have to move the pointer to the next node and so on. So this process is repeated until we reach the end node. So traversal of a linked list is nothing but visiting the nodes of the list. How can we visit the nodes of the linked list? We know the start pointer points to the first node of the linked list. So you have to use one temporary pointer PTR that also points to the first node. After the first node is processed, using the variable pointer, you have to move the pointer to the next node using the statement pointer is equal to pointer of next. Then you can process the second node data. Then again make pointer to move to the third node and so on. So this process is repeated until we reach the end of the linked list. The next operation we are going to discuss is searching for a particular value in a linked list. Suppose we have some elements in the linked list. If I want to perform a search operation, if I want to find out a particular value in the linked list, then how the searching process takes place? If we found the value, then the algorithm returns the address of that node which contains the value. For example, so this is my linked list and I am going to searching for the value 4. So we start with the starting node. So we use a temporary variable PTR. So PTR points to the first node and we check the data of PTR with the value 4, whether they are equal or not. If they are not equal, we have to move to the next node, and we have to compare the second node data 7 with the value 4. Here also they are not equal, so we moved to the third node. My third node data is 3 and my searching value is 4. Again both are different, so move to the next node. My node data is 4 and my searching value is also 4. So now my searched data is found in the linked list, so I can return address of that node. So this is what happening in searching a particular value from the linked list. Then the next operation is insertion. Before insertion, we have to check for the condition overflow. What is overflow? Overflow is a condition that occurs when avail is equal to null. That is, if no free memory is available in the system, then it is called as overflow. If this condition occurs, you cannot insert the element. We have to give the error message. Okay. So normally the linked lists are represented using the pointers. So using the structure, you can represent the node. The node contains the integer item and it contains a pointer which is used to point the next node. You can allocate a memory for the new node during the runtime also. We all know the head pointer always points to the first node in the linked list, that is start. Okay. If the head is null, means it indicates that the linked list is empty. So this is the procedure for inserting a node into the specified position of the linked list. We have some set of elements 20, 40, etc. 100. I want to insert the new node, okay, in a specified position. So you have to point out the current node and the previous node. In between the current node and the previous node, we are going to insert our new node. So we have to make the pointer changes. What are the changes I need to do? The new pointer next is current node and the previous pointer next is new pointer. Okay. So these are the changes I have to make. After insertion, 20 is not at all linked with 40, 20 is linked with 30 and 30 is linked with 40. So in order to make this, you have to do some pointer changes. Okay. Suppose if I want to insert the new node at the beginning of the linked list, then how it can be done? So we know the head pointer always points to the first node. Since the new node is the first node, now the head pointer should point to the new pointer and the new node next pointer is pointing to the previous first node. Okay. So first we have to make the next part of new pointer to the head node, that is 3. After insertion, the new pointer becomes the head node. Okay. So this is what happened during the insertion at the beginning of the linked list. The third case is insertion of a node at the end of the linked list. Okay. So this is the case where we are going to insert the new node at the end of the linked list. So normally in a singly linked list, the next part of the last node is always null. But now it should not be null, it has to point to the new node. Okay. So new pointer of next is null because that is my new last node. So its next pointer is null and the previous pointer next is points to new pointer. Okay. So these are the three cases for insertion. So for insertion, how the node is inserted in a specified position, how the new node is inserted at the beginning of the linked list, how the new node is inserted at the end of the linked list. Similarly, for deletion also, you can delete the node from the linked list in a specified position, or you can delete the first node, or you can delete the last node. Okay. If I have deleted the element at the specified location, for example, consider the node 8 is deleted. Current node specifies the node which is going to be deleted. Okay, after deletion, the previous node next pointer points to the current node next, and you can delete the current pointer. Similarly, if I want to delete the first node, okay, So we know the first node is always pointed by head. So head of next is current of next. Okay. So this is what the pointer changes we need to do for deletion. Thank you all.